Assalamualaikum and good day. My name is Koshum binti Muhammad Nur Sanzali. My matrix number CB25076. Today I would like to present my assignment for the course maintenance technology, which is focused on application root cause analysis or RCA. This RCA study is based on door roller machine that used in food production industry. So this is my agenda for this slide. I would like to explain about introduction of root cause analysis RCA, and then the machine that I use in this study, which is door roller machine, problem description, data collection, RCA method, which is 5 Whys, root cause identification, and the last one is corrective and preventive action. So this is question that I choose, which is question number 1 is about RCA. I choose RCA because this method is very systematic and practical that used in maintenance and engineering industry. RCA doesn't only to fix the problem temporarily, but it helps to identify real cause so that the issue doesn't happen again. I also select RCA because it is widely used in the real industry environment, especially in food manufacturing, where machine reliability and hygiene is very important. By applying RCA to a door roller machine, it allows me to understand how maintenance practice can affect production performance. Therefore, RCA was chosen as the suitable method to analyze the problem and to identify the root cause and propose effective corrective and preventive action. So let's go to the first agenda. As mentioned earlier, root cause analysis (RCA) is a systematic problem-solving method used to identify the underlying cause of the problem rather than just addressing its system. The goal is to identify the fundamental issue so that effective solution can be implemented to prevent the problem from recurring. RCA uses a structured process that involves defining problem, collecting data, identifying causal factors using tools such as the 5 Whys or fishbone diagram, and implementing corrective action. So in next slide, I will introduce the door roller machine in terms of the working principle and also the main function of this machine. The working principle of the door roller machine begins when the power switch is turned on. The motor drives the gear transmission system, which rotates the stainless steel rollers, and then the door is placed onto the conveyor belt and pass through the rollers. The rollers compress the door according to the selected thickness setting, and the last one is the flattened door is transferred smoothly to the output area by the valve. By understanding the working principle of a machine is important because it helps us know how the machine operates and how each part functions. This knowledge allows us to identify where problem occur, determine the root cause accurately, and apply effective maintenance action. In RCA, understanding the working principle helps prevent repeated failures and improve machine reliability. In this slide, I will explain the main parts of door roller machine, which is each component play an important role in ensuring smooth operation and consistent door quality. First, the door thickness adjustment knob allows the operator to set the door thickness between 1 to 25 mm. This helps ensure uniform door thickness for consistent product quality. And next, the machine is equipped with a 3-piece SUS304 stainless steel roller set. These rollers are food grade, corrosion resistant, and easy to clean, making them suitable for food production environments. Then, the enhanced gear transmission system is responsible for transferring power smoothly to the rollers. This system helps maintain stable operation and reduce mechanical stress during long production hours. And then, the anti-deviation belt design ensures that the conveyor belt runs straight and doesn't shift during operation. This helps prevent misalignment and reduce the risk of machine jamming. Next, the waterproof power switch improve operator safety. especially during cleaning and washing activities. It also reduces the risk of electrical damage caused by water exposures. And the last one is the stylistic buffer plates help guide the dough and prevent it from falling off the conveyor during processing. It also support hygiene by minimizing dough spillage around the machine. And overall, understanding this component is very important for identifying potential causes of machine problems and for applying effective maintenance and cleaning practices in the RSCA process. To summarize, the dough rolling machine plays a critical role in bakery production because this machine can increase production speed and ensure consistent dough thickness. They also can reduce worker fatigue and improve efficiency. However, poor maintenance can cause uneven dough, machine breakdowns, and higher repair costs. So one common issue that machine face is getting stuck during operation, which is disrupting production targets. So let's go to the problem description, which is the first step in the RCA that we need to find any failure event or a system. The main problem identified is that the dough rolling machine stops vibrating. This causes production delays and affects daily targets. The issue usually occurs after long hours of continuous operation, indicating a possible maintenance-related problem. So we go to the step number 2 is data collection. Data was collected by using 4W1H method. First is who, the production operator who operates the dough rolling machine, which is the person that related to the machine. Number 2 is what, the dough rolling machine frequently jams and stops during operation, is exactly same with the problem description. Number 3 is where, the issue occurs in the production area, which is the problem is happened, where the problem is happened. Number 4, when, at approximately 3:30 p.m. after about 6 hours of continuous operation. So it's about a time. And the last one is how. Inadequate cleaning causes dough residue to build up on the rollers, leading to machine jamming. So it explains how the event is happening. So let's go to the next step, which is RCA method. I use 5 Whys method to trace potential causes. It starts with a problem, which is the dough rolling machine has stopped while operating. Then it following by first why. Why has the dough rolling machine stopped while operating? Because the dough blocks the roller. Second why. Why does the dough block the roller? Because the dough build up on the rollers. Third why. Why has the dough built up on the rollers? Because the dough get wet and solidify. Fourth why. Why does the dough get wet and solidify? Because after every shift, the machine is cleaned with water, but dough residue might still be present. Fifth why. Why is the cleaning not sufficient? Because the cleaning process might be effective, allowing the dough accumulate on the rollers. By applying RCA method, which is 5 Whys method, I can penalize root cause identification, which is due to insufficient cleaning. Dough residue progressively build up on the rollers, jamming the machine and stopping dough production. So this is the last step, which is corrective and preventive action. So to prevent the machine from experiencing the same problem, the daily cleaning procedure should be reorganized as follows. So this is the new daily cleaning step. First, we need to turn off the machine and unplug before cleaning to ensure safety. Second, all detachable parts such as scrubbers, dries, safety covers and gas must be removed and clean this part using warm water and food safe detergent. Third, harsh chemicals and abrasive tools should be avoided to prevent damage. Fourth, rollers and surrounding areas must be cleaned carefully using a soft brush and damp cloth. and then we need to focus on small areas such as the roller gaps, roller edge, and bad areas where flour and dough can be easily accumulated. And the last one is all part must be dry completely before assembly to prevent mold, bacterial growth, and corrosion. So this is conclusion. In conclusion, Whys RCA study shows that machine learning was not caused by machine failure, but by innovative cleaning practices. By applying root cause analysis, the real problem was identified and addressed using proper corrective and preventive action. This approach helps improve machine performance, reduce downtime, and support consistent production output. RCA is a valuable tool in maintenance management and should be applied to prevent recurring problems in the future. So that concludes my presentation on the application of root cause analysis for the dough roller machine, and thank you for Dr. Morazali bin Daud for your time and attention.